let's consider this example. We've got g of x, which is equal to x cubed plus ax squared plus bx plus c. Do you notice straight away that the coefficient of your x cubed term is already 1? We already know that. So we've shifted all the variables down a value, which means that the coefficient of your x squared term is now a, the coefficient of your x term is just b, and then your constant term is now just c, okay? It's passing through the origin, so that's useful because the origin we know is the coordinate point of 0, 0. So if it's passing through that point, then we can use it on the line. And then it's telling us that we have a tangent, which is given by the equation y equals negative 24x minus 54. A tangent is a straight line graph, and a straight line graph has a gradient, all right? And your gradient is always represented by the value in front of x, okay? So if I were to roughly draw my cubic graph, okay, it's passing through the origin, all right? And at the point, okay, it did say over there, at the point where x is equal to 3, the tangent and the graph are touching each other at the point where x equals 3, okay? And that point over there is what we actually call the point of contact. All right, so it's called the point of contact. So right now what I know is that the point of contact has an x coordinate of 3. We don't know the y coordinate just yet. And we know that the equation of this tangent is y equals 24x minus 54, all right? So what do we know? We kind of have to decode quite a lot of stuff here. First of all, I know an x coordinate at the point of contact, but I don't know the y coordinate, all right? If you've got an x value, you can always find the y value by subbing it into the equation, all right? Now, because this is a point of contact, it's touching both the lines, the blue one and the red one. I don't have the equation to the blue one. I only have the equation to the red one. So to find the y coordinate, we can substitute x equals 3 into the red, into the tangent equation. That's going to give you the missing y value over there. So let's do that quickly. So I'm going to substitute in 24x. Instead of x, we're going to substitute 3 minus 54. And that is giving us a y coordinate of 18. Okay, so that's great. So let's remove that unknown y, and we're going to replace it with 18 because that is now my point of contact. Okay, all right, we're going to use that, but let's just see what we've got here, what else we've got here. The other really important thing to kind of decode from this is that we've got a tangent, and the tangent has a gradient of 24, all right? Now in calculus, I'm sure you're now really used to hearing me saying this, the gradient of your tangent is the derivative, okay? So if the gradient of your tangent is 24, well, that then means that the derivative is 24. Okay, it's equal to 24. Sorry, there's not enough space there. Let me just erase that. The derivative equals 24, all right? So do you agree then that what I can do is I can take the derivative of my g of x function that they gave me, and I'm going to make it equal to 24. Let's see what we can do. Let's see how that works, all right? So let's take the derivative of my g of x function, which is, let's just quickly write it on the side here. G of x was 1x cubed plus ax squared plus bx, and then remember we said that the c was 0 because that's passing through the origin, so c is 0. Okay, right, derivative of g of x is then giving you 3x squared. It's giving you a 2ax, and it's giving you a b. Okay, and we said that the derivative equals gradient of tangent, and the gradient of your tangent was 24. So we're letting it equal to 24. What do we know about the x coordinates at the point where the tangent and the graph touch? We know that the x coordinate was 3. So we can use that. I'm going to substitute 3 into the x's. All right. And that is going to help me kind of just simplify it down just a little bit further. All right, that's going to come down to a an equation of negative 3 minus 6a equals b. Okay, I've just arranged it so that b is then obviously the on its own. Okay, right, so we've used the gradient of the tangent. Now we need to think about this. We've got to, you almost have to kind of invent, you've got to use the information in different ways. Okay, so we've used the information in the gradient of the tangent way. Now we have to use it in a different way. Okay, and the way I'm going to do that is I'm going to take the point of contact, okay, that point of contact over there, which is an x and a y coordinate, which is essentially a point on your blue graph, okay, and if it's a point on your graph, we can substitute it into the equation, all right? So if I take our g of x equation, which we've written over here, I'm going to substitute the point of contact, which is the coordinates of your 3 and 18, into g of x. So you can see how I'm kind of recycling that point and using it in a different way, okay? So that's going to mean that instead of y, we've got 18, and instead of x, we've got 3's. So 3 cubed plus a times by 3 squared plus b times 3. Okay, and that basically simplifies too. I'm going to just go straight to the answer. It's negative 3 equals, in fact, no, let's keep b as the subject of the equation. So it's negative 3 minus 3a equals b. Okay, so we've now created an equation 1 and we've created an equation 2, all right? Both of them are in terms of b. They've both been made equal to b. And if they're both made equal to b, well, then I can take each equation and make them equal to each other. So basically that means that I can take my negative 3 minus 6a and let it equal the negative 3 minus 3a, all right? And that lets us solve for a. A lands up equaling 0, okay, as my value for a. And if I then substitute that 0 back into either equation 1 or equation 2, it actually doesn't matter. We land up with the b value. So negative 3 minus 6, instead of a, we've got 0 equals b. And that lands up being negative 3, which is the b value. Okay, so putting it back, what does your final equation look like? We've got y is equal to x cubed minus, instead of b, we've got 3x, okay? The a value was 0, the c value was 0, so both of those fall away, and that's what we are left with, okay? Right, that was a complex question. There was definitely a lot of stuff to process over there. As I said, you had to take a point and you had to use the same point in different contexts. The one was as a tangent, or the point of contact with a tangent. The other was in terms of just being a point on the line, okay? So I really suggest go and re-watch that again. Go and make sure you really understand it so that when you get that in a test, you're able to identify how to use a point in one situation and in the same point to actually look at it in a different context and use it again. Because that's how you're going to have to be able to interpret those kind of questions. Well done. Okay, that was a tough one. We'll see you next time. Bye-bye.